Hi, myself Santan Krishna, doing my MTech in VIT University, Chennai. Now I'm going to say briefly about design, how to design of the deep beam. Introduction: deep beams are structural elements loaded as a simple beam. They are related as a simple beams in which a significant amount of the top of the load is carried to the support. The total load will be carried to the supports. Uh, the total load will be carried to the support by a compressive force combining the load and the reaction. So the strain distribution is non-linear and the shear deformation becomes significant when compared to the flexure. Deep beams have useful applications in the tall buildings, offshores, uh, structures, and the foundations. Providing a more reinforcement will lead to the convention for placing of concrete and coarse and to reduce the condensation. We will use high strength reinforcement mass and effective design of them. In the deep beams, we will be not using normal reinforcement mass. We'll be using the high strength reinforcement mass so that it would be carrying the more weight. And I will be showing a figure about deep beam. This is a deep beam which was laying in our Chennai city, and I'll be showing one more. And this is also a deep beam. And next I'll be saying about the design steps to go for the how to do a deep beam, so that the step-by-step procedure how to do a deep beam will be getting on, and I will be solving an example regarding the deep beam. So and steps for designing of the deep beam: determine whether the given beam is deep or not, and again we have to check its thickness, and we have to find the design of its flexure and design for the minimum web steel in and its distribution in the beam, and next for design for shear and check for the bearing pressure and check for bearing pressure at the support and point load for the local failure and the reinforcement detailing. Uh, Next, we'll be going for example. Uh, example. And this is a question. A single span D beam has an overall depth of 4.5 meters. Total depth will be around 4.4 meters, and the effective span of around 6.5 meters. That total length will be around 6.5 meters, and the width of the beam is around 400 mm. It supports an UDL of 345 kilonewton per meter over its entire span. UDL, uniform distributed load. Overall, the load will be acting overall all the length of the beam. Use M25 and Fe4, M25 and Fe415 steel, assuming the moderate exposure conditions. Next, first step we have to find out the self weight of the beam. First step we have to find out the self weight of the beam. Formula for the self weight of the beam is equal to thickness into breadth into unit weight. The total thickness would be around 0.4 and the breadth will be 4.5 and the unit weight was constant. We will be assuming as around 25. We will be getting an value around 4 kilonewton per meter. The given live load is around 345 kilonewton per meter. The total load will be adding both the self weight and the live load will be getting around 389 kilonewton per meter. Then we have to go for the given effective span. The given effective span was given around 6.5 meters. Then we have to go for the check for depth from the IS 456 class number 29.1A. Here they are provided that a beam shall be deemed to be deep beam when the ratio of the effective span to the overall depth is equal to L by D is less than 2.0 for it would be less than 2.0 for the simply supported beam and 2.5 for the continuous beams. If the depth would be around less than 2.0 for the simply supported, it is safe, and if it is less than 2.5 for the continuous beams, and it is safe. The DPM is compelling with the requirements of 29.2 and 29.3 shall be deemed to satisfy the provision of the shear. From the formula L by D, the overall L by D, we will be calculating L by D 6.5 by 4.4. We will be getting around 1.47. It was less than 2, so that the given beam is a D D beam. From that we can be getting the given beam is a D beam. Next we'll be going for the further. Next, we have to find out the check for the thickness. The condition for the check for the thickness is L by T less than 50, comma D by T less than 25. First, we will be finding L by T 6.4 length. The overall next span will be getting around 6.4. Thickness we will have assumed as 0.4. We would be getting around 16.25, which is less than 50. Okay, it has been satisfied. Next we will be finding d by t. D depth is equal to 4.4 and thickness we have assumed 0.4. We will be getting around 11, which is less than 25. Then it was safe. Then again we will be going for design for flexure. In the flexure, the total load was given by 389 kilonewton per meter. The momentum, as it was a uniform distributed load, the formula for the uniform distributed for simply support beam is WL square by 8. Then we will be calculating the momentum for the simply supported beam. The total weight was acting, the total weight 389, length is 6.5 into 6.5 divided by 8, we would be getting around 2054.40 kilonewton per meter. Next, we have to find out the lever arm. For the lever arm, we have some conditions which are provided in the IS 4567. I think the page number will be around 55 from the class number 29.2. Lever arm. The lever arm is the lever arm Z. The lever arm is indicated by Z of a D beam shall be determined as below. For the simply supported beams, if you go for get around simply supported beam, we should use the formula 0.2 into L plus 2D, where L by D is less than equal to 2 and Z is equal to 0.6L, where L by D is less than equal to 1. It is for simply supported beams. If we go for the continuous beams, Z is equal to 0.2 into thickness plus 1.5 by D, where L is less than T by D and less than T.5, where Z is equal to 0.5, where L by D is less than 1, where L is the effective span taken as the center to center distance between the supports of 1.5 times to the 1.5 times then the clear span, whichever is similar to, and D is the overall depth. From that we'll be getting D is the overall depth. This is the clear span which is similar. You should see the clear span which is similar. Then we'll be calculating for the lever arm 0.2 into 6500, the effective length, plus 2 into 4000 pound. We will be getting around 3060 mm. Then we will be taking Z, the lever arm Z value is 3060 mm. For mu, Fs into As into G. For momentum, this was the formula. Fs into, from this we will be finding, we know moment mu, Fs and Z. From this we will be finding out area of the steel. Area of the steel, mu is equal to 2054 into 10 power 6 by 0.87 into Fe, steel 415, Z 3064. We will be getting of the area steel is equal to 1857 mm square. We should assume the diameter of the bar around 20 mm. Then area of the bar will be getting 5 by 4 into D square. Then we will be getting the area of the bar will be getting around 314 mm square. Then you will be finding out the number of the bars. The total number of the bars will be finding out by the total area of the steel divided by the area of the bar. We will be getting the total number of the bars. And the provided area is will be getting 1884 mm square. The percent of the steel, for finding out the total percent of the steel in the beam will be the formula AST by BD. It is also given in the code book. AST by D. Total area of steel we have find out around 1884. Breadth is 0.4 and depth is 4.4. We will be getting the area of the steel around 1.07%. Then we should be finding out the zone of the placement. Zone of the placement is 0.25 D minus 0.05 I and 0.25 into D. D will be getting a value around 4400 minus 0.05 I and the total length around 6.5. Overall length is will be 6500. 6500. I will be getting around 775 mm. Now, from we should be providing the cover. The cover by cover will be taking around 40 mm. Further reinforcement. Provide 20 mm of the diameter. The cover will be taking 40 mm. providing 20 mm diameter of the bars at 1200 mm spacing. For the vertical steel, 12% of the main steel is equal to 4,800 square. The vertical steel, we should be using the 12% of the main steel, and the area of the one phase, the total main steel divided by 2 will be getting area of the one phase. The total is around 4,800. We will be getting around 2,400 mm square. For assume bar diameter, we will be assuming the diameter of the bar around 10 mm. Then we will be getting a area next similarly pi by 4 into b square. And we will be getting around 7805 mm square. Then horizontal steel 2% of the main steel. Horizontal steel will be 2% of the total main steel into the 2% will be getting around 800 mm. Okay, then area of one phase divided by 2 as it contains two phases will be for one phase 400 mm square. Assume would be assuming around diameter is equal to 12 mm and the area is equal to pi by 4 into d square. We'll be getting around 1130.4 mm square. For find will total number of the steel and the area of the steel and diameter of the bars will be getting around the how many bars are provided for that. We will be getting around 4. The spacing, the 1000 divided by 4 will be getting around 250 mm. Next we have to go for the check for shear. Tau is equal to V by Td. Shear tau is equal to V by Td. We know that 1.40 Newton per mm square. So V by Td will be getting the shear around 1.40 Newton per mm square, and then for the maximum shear 3.1 Newton per mm square as it was given in the IS 456 for the maximum shear. Hence we got the shear around 1.404, which is less than 3.1 Newton per second. Hence it is safe. Now we have to find out the VC. VC is equal to 0.72 into T minus 0.32 into small a into small b into thickness into F, capital F into T. For finding of Ft, we would be using the formula 0.5 root over FCK. For A, we L by 3. L by 3 because of the satisfying shear force and the bending moment of principle. We will be using AB as equal to L by 3 because it is satisfying the shear force and the bending moment of principle. AB is equal to 6.5 by 3 is equal to 2166 mm. Now for FT we will be using value 2.5 Newton per mm square. Then we will be getting by calculating this all these we will be getting VC is equal to 1.68 kilonewton, where VC is greater than the total load. Next, the bearing strength of support. There is as bearing strength of the support, and there was no columns were given in the question. And the condition is 0.2 into L. 0.2. The total and the span will be around 6,500. The total height is 6,500. We will be getting 0.28 into 6,500 will be getting around 3,000, and the total width will be 800 mm. Then we will be finding out the shear tau V by D into D. Tau V, the tau V value is equal to 2528.5, and breadth is equal to 800, and depth is equal to 400 is equal to 7.59. And the bearing stress, we have to find out the bearing stress whether the section is safe or not. For the formula for the bearing stress is 0.45 FCK. 0.45 we are using around M25 grade concrete. 0.45 into 25 we will be getting around 11.25, which is less than 7.9 is less than 11.25. Hence our section is safe. Next, for this, if they actually we are doing this problem on continuous beam. If they are given for the simply supported beam as provided in the IS 456, here continuous beam it should be less than 2.5, and if you go for the simply supported, it should be less than 2.0. We should be keep it on the mind. But, so, thank you.